Welcome to our channel. Today, we're going to dive into the world of high-tech horticulture to explore a really fascinating question. It's one that sits right at the intersection of botany and pure engineering, and it all comes down to a single, remarkable goal. So how is it possible to take a single plant, one with its own genetic blueprint for how it's supposed to grow, and basically convince it to produce a harvest so big it seems to defy its own biology? And we're not talking about some kind of miracle fertilizer or exotic genetics here. No, the answer is way more clever. It's about architecture, it's about physics, and it's about learning how to make a plant break its own rules. You see, if you just let a plant grow on its own, it naturally takes on that classic Christmas tree shape. You get one main, dominant flower that reaches straight up for the light. But for an indoor cultivator, that beautiful, natural shape, well, it's actually a huge design flaw. The goal is totally different. Dozens of perfectly uniform flowers all arranged in this flat, horizontal canopy. So that presents a pretty big challenge, right? How do you convince a plant that's programmed to grow up to instead grow out? To really understand why this horizontal shape is so important, we need to step back from biology for just a second and look at the physics of the situation. There's a fundamental, unchangeable law of the universe that every single indoor grower is constantly fighting against. It's called the inverse square law of light. Now, I know that sounds complicated, but the idea is actually super simple. Light just gets dramatically weaker over a very short distance. So imagine you have a grow light hanging overhead. The very top of the plant is bathing in all this perfect energy. But a branch just a few inches below that, it's getting way less. And a foot below the top, it might as well be in the shade. And this one simple rule of physics, it changes everything. It means that on a tall Christmas tree-shaped plant, most of the branches are essentially starving for light. They just aren't getting the energy they need, and that results in smaller, lower-quality flowers. So that natural, beautiful shape, it suddenly becomes a blueprint for total inefficiency. Okay, so the most common solution to this problem seems pretty straightforward, right? You just use a net to force the plant to grow sideways. And for years, growers have used really inexpensive plastic or nylon netting to do exactly that. But, and this is where things get really interesting, this simple fix comes with a deeply unsettling and often totally invisible problem. Let's look at why. When you start comparing the different materials used for these nets, the problem becomes crystal clear. So take a look at the typical nylon netting. Yeah, sure, the initial cost is low, but then look at the columns for fiber shedding and pathogen risk. These cheap materials are porous, which means they can trap moisture and literally become a breeding ground for mold. And even worse, they physically start to fall apart over time. And this is the part that I found truly shocking. As the plant's flowers develop, they become incredibly sticky and covered in resin. Well, that cheap netting, it starts shedding microscopic plastic fibers. And those fibers, they get permanently fused to the final product. We're talking about microplastic contamination that is physically impossible to remove. Please like and subscribe. It really helps our channel a lot. Okay, so if the cheap, common solution is actually a contaminant, then what is the real answer? Well, the truly elegant solution isn't about brute force. It's about something much more sophisticated. It's about hacking the plant's internal communication system and, well, basically staging a hormonal revolution. It all comes down to a biological concept called apical dominance. So in simple terms, plants are hardwired to have a single leader, that main stem that grows the fastest and the tallest. This whole process is controlled by a hormone called auxin, which is produced at the very top of the plant. You can think of auxin as a chemical message from a king, sent down through the plant, telling all the side branches, hey, you stay small, I'm in charge here. So what do you think happens if you gently depose the king? By simply bending that main stem so that it's horizontal, you interrupt the flow of that hormonal message. All of those side branches, they suddenly stop getting the signal to stay small. In fact, each one of them starts to think it's the new leader, and they all start growing upwards towards the light with equal energy. You've just created a revolution, all with a simple change in geometry. This brilliant technique, the one that combines that biological hack with a physical structure, it has a name. It's called the screen of green, or SCROG for short. And this is the real secret to turning a single plant into a hyper-efficient, uniform harvest. The process itself is meticulous. It's almost like weaving a living tapestry. So first, the plant is encouraged to grow bushier when it's young. Then, a rigid, cleanable screen is placed above it. As the branches grow up and reach the screen, they aren't allowed to just grow through it. No. Instead, the grower carefully tucks and weaves them underneath, guiding them horizontally to fill out the entire grid. And this goes on for weeks until you have this perfect flat carpet of green all ready for the flowering stage. But of course, nature doesn't always cooperate perfectly. You're always going to have some branches that are just more vigorous, that stretch for the light faster than their neighbors, and they threaten to break that perfectly flat canopy. So what's the next level trick that a master grower uses to maintain absolute control? They use an advanced technique that sounds a little brutal, but it's incredibly effective. It's called supercropping. It involves very carefully pinching and rolling a stem that's getting too tall until the inner fibers are crushed, but the outer layer stays intact. This lets the branch be bent at a sharp 90-degree angle, instantly leveling it with the rest of the canopy. And the way the plant responds is amazing. It heals by building this thick, reinforced knuckle right at the bend, which can actually improve nutrient flow to that whole branch. This level of meticulous control, it's just incredible to witness. But it's not without its costs. Achieving this perfect sea of green involves a really serious trade-off, one that completely changes the equation when it comes to time, labor, and even risk. And you can see that trade-off right here. The results, they're undeniable. Your yield per square foot goes way up, and the quality is incredibly consistent. No more of those little B-grade flowers. But the cost is all on the right side of the chart. The labor involved in daily training is significant. And that dense, beautiful canopy creates a very humid environment, which dramatically increases the risk of mold if the airflow isn't managed perfectly. So when you step back and you look at the whole process, the manipulation of light with physics, the hijacking of hormones, the meticulous structural training, you really see something extraordinary. It's a method that's so intensive, so deeply manipulative of a plant's natural life cycle, that it really makes you wonder, at what point does this stop being agriculture and start becoming biological engineering? Thanks for watching. This content does not constitute medical advice, legal advice, or recommendations for the use, self-treatment, or consumption of any substance.